It's called Jesus Christ and the Law of Probability. After examining only 48 different prophecies, even though he could have used 456, Professor Emeritus of Science at Westmont College, Peter Stoner, has calculated the probability of one man fulfilling the major prophecies made concerning Jesus Christ. He just used 48 of the possible 456 that he did fulfill from Old and New Testament, okay? Bear in mind, these Old Testament prophecies were written by different unrelated authors of the Bible hundreds and hundreds of years earlier. It's another thing that makes it even more astounding. 12 different classes of 600 different college students worked out the estimates. The students carefully weighed all the factors, discussed each prophecy at length, and examined the various circumstances which might indicate that men had conspired together to fulfill a particular prophecy. They made their estimates conservative enough so that there was finally unanimous agreement among even the most skeptical students. Not only that, but when Professor Stoner took their estimates and finally he made them even more conservative. He also encouraged other skeptics and scientists to make their own estimates to prove that his conclusions were more than fair, meaning he underestimated the actual final odds that we're going to be looking at here. Finally, he submitted his figures to review to a committee of American scientific affiliation. Upon examination, they verified that his calculations were dependable and accurate in regard to the scientific material presented. For example, concerning Micah 5:2, where it states that the Messiah would be born in Bethlehem, Stoner and his students determined the average population of Bethlehem from the time of Micah to the present. They then divided it by the average population of the earth during the same period. They then concluded that the chance of one man being born in Bethlehem was 2.8 times 10 to the fifth power, or rounded out 1 in 300,000. In the final calculation, Stoner used 48 prophecies, even though he could have used 456, and arrived at an extremely conservative estimate that the probability of the 48 prophecies being fulfilled by one person is 10 to the 157th power. That's the odds. 10 to the 157th power. How large is 10 to the 157th power? Well, that's the number 10 to the, basically it's 10 to the 157 contains 157 zeros. That's how big the number is. I mean, it's so far beyond a trillion, you can't even comprehend it. So the odds of, it would be like 1 to the 157th power. We're talking odds that you can't even possibly ever conceive. And we're going to make this more real to you in a second here, that we're going to give you an actual description of what this would be like, the actual odds of this. Let us try to illustrate the number using electrons. Okay? Electrons are very, very small objects. They are smaller than atoms. They're part of an atom. Okay? Protons, neutrons, electrons. Anyway, it would take 2.5 times 10 to the 15th power of them, the 15th power, laid side by side just to make 1 inch. Okay? So this is how small they are. 2.5 times 10 to the 15th power just to make a line of them 1 inch long. Even if we counted 4 electrons every second and counted day and night, it would still take us 19 million years just to count a line of electrons 1 inch long. It's a lot of electrons for 1 inch. It takes us 19 million years to count that many. How many electrons would there be then if we were dealing with 10 to the 157th power? Okay? Because we're just talking about 10 to the 2.5 times 10 to the 15th power. What if we go to the 157th power? Okay, let's imagine. Imagine building a solid ball of electrons that would extend in all directions from the Earth 6 billion light years. 6 billion light years. Just electrons. It's a ball. A ball of electrons. The tiniest particles just about that there are, that we know of. I know there's quarks and there's tachyons and stuff like that, but I'm just saying, for argument's sake. solid ball of electrons that would extend in all directions from the Earth 6 billion light years. The distance in miles of just one light year is 6.4 trillion miles. That's just one light year. This is 6 billion light years. So, the distance of just one light year is 6.4 trillion miles. That would be a big ball. No pun intended. But not big enough to measure 10 to the 157th power of electrons. Still not big enough. In order to do that, you must take that big ball of electrons, reaching the length of 6 billion light years long in all directions, and multiply it by 6 times 10 to the 28th power. How big is that? It's the length of space required to store trillions and trillions and trillions of the same gigantic balls of these electrons, and even more. In fact, the space required to store all of these balls combined together would just start to scratch the surface of the number of electrons we would need to really accurately speak of 10 to the 157th power. Assuming that you have some idea of the number of electrons we're talking about at this point, imagine marking just one of the electrons in one of the balls that extend out, was it 6 billion light years or something in all directions? Yeah, 6 billion light years in all directions. Let me start over. Imagine just marking one of those electrons in that huge number, stirring them all up, then appointing one person to travel in a rocket for as long as he wants, anywhere he wants to go, and now tell him to stop the rocket in space, take a high-powered microscope, because that's what it would require to see an electron, and find that one marked electron in the 6 billions of millions of miles or billions of light years in all directions. Find that one electron. You ever heard of the needle in the haystack? Well, this is like the needle in the haystack on, like, cosmic steroids or something. It doesn't even remotely do it justice, okay? So tell them to stop the rocket in space, take a high-powered microscope, and find that one marked electron. What do you think his chances are of being successful? Well, that would be 10 to the 157th power. Remember, this number represents the chances of only 48 prophecies coming true regarding Jesus Christ from the Old Testament, whereas we could have used 456 prophecies. So, what do you say? I mean, you can't even comprehend that number I just talked about, but we could have used 456? It's beyond human comprehension. Just like God, beyond human comprehension. In financial terms, is there anyone who would not invest in a financial venture if the chance of failure was only 1 in 10 to the 157th power? No, because you would have virtually, essentially no chance of ever possibly failing. This kind of sure investment is what we are offered by God for belief of salvation in Jesus Christ, the Messiah. Think about that. All this illustrates why it is absolutely impossible for anyone to have fulfilled the messianic prophecies by chance. And here we got these devils up here with this remote view and say, oh, no, none of that happened. No, sorry, you're a liar. This is the kind of evidence that proves there must be a God who supernaturally gave us this information. Let's keep in mind that we've only illustrated 48 out of the 456 messianic prophecies already fulfilled. Out of the over 8,000 total verses in the Bible of prophecy, of which thousands of verses have already been fulfilled already as well. So, it's just laughable. It's just, Well, if somebody says, well, what do you base your faith on? Well, this is a good thing to take them to right here. Granted, I'm not saying it's the only thing, but it's sure pretty much overwhelmingly convincing. How are you going to debunk this? Well, I don't believe it. Oh, well, okay, there is a way which seemeth right unto a man, but the end thereof are the ways of death. And the fool has said in his heart, there is no God. You know. The heart is deceitful above all things and desperately wicked. Who can know it? He who trusteth in his own heart is a fool. That's the verses that kind of come to mind for me when I think about somebody saying, well, I don't believe it. Well, the facts are not on your